Good morning, dear students. Let's start with Unit 15, Polymer. The word polymer is coined from two Greek words. Poly means many and mer means part. So, polymer is a large molecule having high molecular mass, and it is also referred to as a macromolecule. But this macromolecule is formed by joining of repeating structural units. Such repeat structural units are known as monomers, and they are linked together by covalent bond. And process of formation of polymers from monomers is called polymerization. Now, important statement that comes here is all polymers are macromolecules, but all macromolecules are not polymers. See, if you want to classify a substance as a polymer, it should be made up of monomeric units. Now, chlorophyll is also a macromolecule, but we cannot call chlorophyll as a polymer because it is not made up of monomeric units. So a substance is classified as a polymer only if it is made up of monomeric units, right? So you can write this point. Macromolecule is a giant molecule having high molecular mass which may or may not contain the monomeric units, example chlorophyll. But polymer is a macromolecule and it is formed from repeat units called monomers. Now we see the examples of the various polymers. This is the polythene polymer. This is made up from ethene, and ethene polymerizes to form the polythene polymer. This is the repeating unit, that this unit keep on repeating and you get the polymer. This is an example of addition polymerization. Here the same monomeric unit keeps on adding and we get the polymer. Now see the next example, hexamethylene diamine and adipic acid. They polymerize to form nylon 6,6. Now let me tell you why the name 6,6 has come. Here it has 6 carbon atom. Here also you can find 6 carbon atom, 4, 5 and 6 carbon atoms. Secondly, you should know that this nylon 6,6 it has the amide linkage, C double bond O NH linkage. So it is also called as what? Polyamide. This is the second thing. Third thing you should know about this polymer is that it is an example of condensation polymerization. When these molecules join, small molecules are eliminated like water. So that is why we say that such polymers where there is elimination of small molecules, so such polymers are known as condensation polymerization. We will study in detail about this. Then we come to how these polymers are classified. So the first way we can classify polymer is on the basis of source. For example, we can say that there are 3 types on the basis of source. One is a natural polymer, semi-synthetic polymer, synthetic polymer. See, natural polymer is found in plants and animals. Okay, for example, proteins, cellulose, starch, resins, rubber, they all are natural polymers. They all are formed from the repeating structural unit. So they all are formed from monomers. For example, cellulose, starch, the monomer is glucose units. Okay. Then proteins, the monomer is amino acids. Then semi-synthetic polymers. Semi-synthetic polymer means partially they are chemicals and partially they are found from these sources like plants. Cellulose is a plant source. Cellulose is coming from the plants. So cellulose acetate, cellulose nitrate, these are semi-synthetic polymers. Synthetic means totally man-made polymers. The example of such polymer is plastic, which is a polythene is an example. Synthetic fibers, example nylon 6,6. Synthetic rubber, Buna S. So here the classification is on the basis of source, that from where they are coming from. The question that has appeared in the board from this topic is, which of the following is a natural polymer? I think this is a very easy question. Buna S, protein, PVC. So we know that protein is a natural polymer. Then the second classification is on the basis of structure. On the basis of structure, we have linear polymers, branch chain polymers, cross-linked or network polymers. So linear polymers they consist of long and straight chains. right? So example is high density polythene and polyvinyl chloride. So you can see the long and straight chains. So they come, so this kind of polymer is having long and straight chain is called the linear polymer. Then we come to the branch chain polymer. In this, there are linear chains, and among the linear chains, there are certain branches. So this is an example of a branch chain polymer. Example you need to remember, low density polythene. So these are very important, HDP and LDP. High density polythene is a linear polymer and low density polythene is a branch chain polymer. So the third is cross-linked or network polymer. Now cross-linked or network polymer, in this, what happens, there are linear chains and the linear chains have strong covalent bonds between them. So cross-linked or network polymers are formed from bifunctional or trifunctional monomers, and they contain strong covalent bond between various linear polymer chains. So they are strong covalent bond. Example is bakelite and melamine. So this question has appeared in the board, that which is correct about cross-linked or network polymers. They contain covalent bonds between various linear polymer chains, and they contain strong covalent bonds in polymer chain. See, they contain covalent bonds between various linear polymer chains. So very minute difference is there. So these kind of questions do appear in the NEET examination. So we can say here that there are strong covalent bonds between linear polymer chains. Okay, fine. So this is the classification on the basis of structure of polymers. Then we come to the addition classification based on mode of polymerization. What mode is adopted, whether it is an addition polymer or a condensation polymer. See, in addition polymer, what happens, the small monomeric units, they keep on adding. So they keep on adding to generate the polymer. And in condensation polymerization, what happens is that the monomeric units, they join and there is elimination of certain small molecules. So this kind of polymerization is known as condensation polymers. Let's see now in detail. Addition polymers. The addition polymers are formed by repeated addition of monomer molecules. So monomer molecules keep on adding, and such monomer molecules should possess a double or triple bond. For example, the formation of polythene from ethene and polypropene from propene. The addition polymer formed by the polymerization of a single monomeric species. If a single monomeric species is used, then such kind of polymer is also known as homopolymer. That means homo means same. Same monomeric unit keep on repeating to form the polymer, and such polymers are known as homopolymers. The polymers are also formed when two different monomeric units, they add. For example, we see this buna-S. In the formation of buna-S, there is 1,3-butadiene and styrene. So 1,3-butadiene and styrene, they join together to form the polymer buna-S. As different monomeric units are involved in the process of polymerization, so this is known as a copolymer. Now here I have written the structure of styrene like this. Whatever way is easy for you, you can learn accordingly. So distinguish between homopolymer and copolymer. Give example in each case. So homopolymer is a polymer in which we have single monomeric species, and copolymer is a polymer in which we have two different monomeric species. And example, we know polythene, and in case of copolymer, it is buna-S. Now we come to the condensation polymer. The condensation polymers are formed by the repeated condensation reaction between two different bifunctional or trifunctional monomeric units. So let me first explain the meaning of bifunctional. For example, you see this adipic acid. There are two functional groups here. So it's a bifunctional monomeric unit. This is also a bifunctional monomeric unit. There can be trifunctional also. So in the condensation polymerization, there is a condensation reaction between these two different bifunctional monomeric units, and there is elimination of small molecules such as water, alcohol. Small molecules, they are eliminated. So example of condensation polymer is terylene, nylon 6,6, nylon 6. So here they have depicted this nylon 6,6 formation, hexamethylene diamine and adipic acid, right? So this is a example of condensation polymerization. Then we come to the classification based on molecular forces. What kind of molecular forces are operating between the monomeric units? So first is, on the basis of this molecular forces, we have different kind of polymers. They can be elastomers, they can be fibers, they can be thermoplastic polymers, or they can be thermosetting polymers. Let's see about elastomers. See, elastomers, the example is rubber, and it has elastic properties, and the important thing you need to learn is that it has weakest intermolecular forces. So the polymer chains are held together by weakest intermolecular forces, right? There are certain crosslinks in between the chains which help the polymer to retract to its original position. You find that when you stretch the rubber, it comes back to its original position. And what is the reason for that? That there are certain crosslinks between the chains which help the polymer to come back to its original position once the force is released. So the examples of elastomers are bunias, bunion, and neoprene. We will study in detail about this in the subsequent sections. Then we come to the fibers. So what you need to learn about elastomer is that they have the weakest intermolecular forces, right? Then we come to the fibers. So fibers have high tensile strength and high modulus, right? And second thing you need to know is that they have strong intermolecular forces. The strong intermolecular forces such as hydrogen bonding. So important example about this is polyamides, which are nylon 6,6, or polyesters, terylene. Now, important thing you need to learn about this fiber is that there are strong forces. As a result of these strong forces, there is close packing of chains, and this impart crystalline nature. Okay, so the strong forces lead to close packing of chains and thus impart crystalline nature to such fibers. So about fibers, important thing is that they have strong intermolecular forces. They have high tensile strength. High tensile strength means they have high pulling strength, means they don't break. So, and they have high modulus. Then we come to the third kind of polymers, that is what? Thermoplastic polymers. Thermoplastic polymers, they are linear or slightly branched long chain molecules capable of repeated softening on heating and hardening on cooling. So thermoplastic, they can be softened on heating and they get hardened on cooling, and they possess, this is important, they possess intermolecular forces of attraction intermediate between elastomers and fibers. So the intermolecular forces of attraction, they lie in between elastomers and fiber. This is elastomer, this is fiber, in between comes the thermoplastic. The examples are very important. Example of thermoplastic polymer is polythene, polystyrene, and polyvinyls. And then we come to the thermosetting polymer. These polymers are cross-linked or heavily branched molecule, and they on heating undergo excessive cross-linking in molds and again become infusible. They cannot be reused. Once they are set, you cannot reuse them. So examples are bakelite, urea formaldehyde resin. Now the question generally come, arrange these polymers on the basis of their intermolecular forces. So weakest intermolecular forces are present in elastomers, strongest in these fibers, and thermoplastic comes in between elastomers and fibers, but thermosetting will come after this thermoplastic. So they are very near to fibers, but fibers are the strongest forces. So fibers are the, right? So this you need to know. Then see the question, arrange the following polymer in increasing order of intermolecular forces. PVC, nylon 6,6, natural rubber. Natural rubber is your what? It's an elastomer, so weakest force. Polyvinyl chloride is your thermoplastic, and nylon 6,6 is your fiber. So he has asked through examples the same question, that is fibers weakest force, strongest force. Natural rubber has the elastomers have the weakest force, and nylon 6,6 has the fibers have the strongest force. So this is an example of fibers. And PVC, this thermoplastic, have intermediate intermolecular forces of attraction. So the order will be natural rubber. After natural rubber, we'll have PVC, and after PVC, we'll have nylon 6,6. Okay, so we move to the next topic. Let's discuss about the types of polymerization reactions. There are two types of polymerization reaction. The addition polymerization, also known as chain growth polymerization. Condensation polymerization, also known as step growth polymerization. Let's first discuss about addition polymerization or chain growth polymerization. In this type of polymerization, the molecules of the same monomer or different monomer, they add together on a large scale to form a polymer. The monomers generally are unsaturated compound, for example, alkenes. In this mode of polymerization, there is an increase in the length of the chain, and this generally takes place through the formation of free radicals or ionic species. The free radical governed addition is the most common mode. Let's discuss about the free radical mechanism. In the free radical mechanism, there are three steps. We have already studied when radicals are involved, the following steps are generally there. First is the chain initiation step, second is the chain propagating step, and third is the chain terminating step. First, what is done, that ethene and benzoyl peroxide, which is an initiator or what you call as a catalyst, is taken in a flask. They are heated or they are exposed to light. When the mixture is exposed to light, the following reactions take place. So we see that in the chain initiation step, the benzoyl peroxide first generates the phenyl radical. This phenyl radical adds to a molecule of ethene to form another free radical. This happens in the chain initiation step. Then in the chain propagation step, this radical adds to another molecule of ethene to form a new and bigger radical, and the reaction is carried forward, and so large number of ethene molecules add this way and the chain keeps on growing. Now in the chain terminating step, what happens? The radicals, they join together and they form the polymerized product. So in this, what happens? There are three steps: chain initiation leading to the formation of phenyl radical. This phenyl radical generates another radical. In the chain propagating step, this radical which has been generated in chain initiation step adds to a molecule of ethene to form a bigger radical, and in this way the chain keep on growing, and in the chain terminating step the radicals, they join to form the polymerized product. Now this topic is very important. So question generally appears in the board. Write the mechanism of free radical polymerization of ethene. So you are supposed to write all these steps. Or what is the role of benzoyl peroxide in the polymerization of ethene? So we know that benzoyl peroxide is an initiator or it is a catalyst. Other catalysts can also be used, such as acetyl peroxide, tertiary butyl peroxide. These can also be used in the this free radical mechanisms. Let's discuss about the preparation of some important addition polymers. First is polythene. There are two types of polythene: low density polythene and high density polythene. This low density polythene is obtained by the polymerization of ethene under a high pressure of 1000 to 2000 atmosphere and temperature of 350 to 570 Kelvin in the presence of traces of dioxygen or a peroxide initiator catalyst. The low density polythene is obtained by free radical addition and it has a highly branched structure. Then it is chemically inert, it is tough but flexible, it is a poor conductor of electricity. So it is used in the insulation of electricity carrying wires, manufacture of squeeze bottles, toys and flexible pipes. So the question that will come from this topic will be, write the properties and uses of low density polythene. So you will write, they are chemically inert, they are tough but flexible, they are poor conductor of electricity. These are the properties, and the uses you will write, it is used in the insulation of electricity carrying wires. It is used in the manufacture of squeeze bottles, toys and flexible pipes. Then you need to know that low density polythene has a highly branched structure. Then you need to know the pressure and temperature condition. The pressure is 1000 to 2000 atmosphere and temperature is 350 to 570 Kelvin, and in the presence of traces such as peroxide initiator. So this you need to know. Each line of this text is very important in this chapter. High density polythene. Now high density polythene is formed when there is addition polymerization of ethane and it takes place in a solvent in the presence of catalyst such as Ziegler-Natta catalyst. Now what is this Ziegler-Natta catalyst? It is triethyl aluminium and titanium tetrachloride. So this is triethyl aluminium and titanium tetrachloride is Ziegler-Natta catalyst. So this Ziegler-Natta catalyst is used in the preparation of this high density polythene. So it is formed when addition polymerization of ethane take place in a hydrocarbon solvent in the presence of a catalyst such as Ziegler-Natta catalyst, and the temperature is 333 Kelvin to 343 Kelvin and pressure is 6 to 7 atmosphere. So you can understand the contrast between the preparations of the two, low density polythene and high density polythene. This high density polythene is linear molecule. It has a high density due to close packing. It is chemically inert, more tough and hard, and it is used in the manufacture of buckets, dustbins, bottles, pipes. Now the question that can come is, write the properties and uses of HDP. So the properties are that it is chemically inert, it is more tough and hard. Uses are, it is used in the manufacture of bucket, dustbin, bottles, pipes. Structural difference between the low density polythene and high density polythene is that low density has a highly branched structure and high density polythene is a linear molecule. Okay, so this is very important. So the questions can come, differentiate between low density polythene and high density polythene, properties and uses of low density polythene or high density polythene, anything can be asked. Now the next addition polymer is Teflon, which is also known as polytetrafluoroethene, and this the monomer is tetrafluoroethene. This tetrafluoroethene is heated in the presence of a catalyst such as persulfate catalyst or any free radical catalyst and at very high pressure to get Teflon. So this is also used in the oil seals, gaskets and non-stick surfaces, non-stick surface coated utensils like your non-stick tawa that has a coating of Teflon. So the question that can come from this topic is, name the polymer used in the making of non-stick cooking utensils. So the polymer is Teflon, right? Then we come to polyacrylonitrile. This polyacrylonitrile is again an addition polymer, and acrylonitrile polymerizes in the presence of peroxide catalyst and it forms the polyacrylonitrile. So polyacrylonitrile is a substitute of wool and it is used in making fibers such as Orlon or acrylon. So polyacrylonitrile is also known as PAN. It is also known as polyacrylonitrile, PAN. So this is a addition polymer. Now see, I'll tell you the way to remember, because these structures normally the students are not able to write. We know the structure of ethene that everyone knows. If you replace hydrogen by fluorine, it becomes tetrafluoroethene, right? And if you replace one hydrogen from ethene with CN group, then it becomes your acrylonitrile. So CH2 double bond CH, Now if you replace one hydrogen of ethene with C6H5 group, then it becomes your styrene. You can write this way or this way. So this is the way to write. And the question that come from this topic will be, write the name and structure of monomer which is used for getting the polymer polythene. So polythene, you can have to write the structure and name. Ethene is the monomer. Bunaz, it is 1,3-butadiene and styrene. Nylon 6,6. Hexamethylene, diamine and adipic acid. You need to know the structures also. Teflon, it is tetrafluoroethene. Then PAN, polyacrylonitrile, the monomer is acrylonitrile. Teflon, the monomer is tetrafluoroethene. So you must revise their structures. That is important.